I will turn the floor over to Kieran.
All right. Thanks, Andrew. Hope everyone were able to register. It's metachat.io. So good afternoon, everyone. My name is Kiran Kakralamudi. I'm the organizer of digital health at RTP Meetup Group. We pretty much conduct events to discuss a variety of topics in healthcare spectrum, whether it's providers, pharma, and drug development and insurance, and all the entire healthcare spectrum, even public health as well. So our topics are generally centered around bringing healthcare issues and the digital technology solutions that address those issues. So again, thank you for attending today's event. Today's event is topic is conversational agents in healthcare. So we have two speakers today. Ashley Array. She is a System Executive Director of Care Access and Service Integration at UNC Healthcare. So Ashley will talk about where these conversational agents are applicable in healthcare and how UNC Health System is leveraging those solutions. And we have the other speaker who has been talking. He is Andrew Shirk. He is a senior software developer at UNC Lineberger Comprehensive Cancer Center. So Andrew has done some significant work on conversational agents, and he will explain the technology behind these conversational agents and their particular use in healthcare as well. So just some housekeeping items. Please make sure you're on mute. You're automatically put on mute when you joined. And please type your questions in the Zoom chat window. Ashley and Andrew will answer those at the end of the meeting. So please stick around. The chat board that registered you to the raffle for Alexa will draw the winner at the end. And we will announce the name. So that's you please register for that raffle. With that, I would like to hand it over to Ashley and Andrew, and they will give more introductions about themselves. Thank you.
Hi, everyone. I'm hoping you all can hear me well. I'll look for your nods. Great. I always have to check that because I don't always trust my computer audio. All right. So thank you all so much for inviting me here. I'm really happy to be here and share a little bit about what UNC Health has been up to, but then also share with you some of the challenges that we face that we hope could be remedied by leveraging chatbots. Just a little bit more about me. I've been with UNC Health for over a decade and have experience in both operations and clinic management, as well as with access principles. And I'd like to give a little more background on my team at UNC Health, Care Access and Service Integration. We consist of 3 key groups that all work together and to improve access and the experience for our patients. So the Care Access component of CASI, as we shorten it to, the CA piece, focuses on optimizing scheduling processes and templates to reduce wait times. And we leverage a coaching team to help us help guide the clinics on access principles. And we pair them up with our template build team that actually builds out our EHR templates in a way that's access supportive and user-friendly, but of course, ultimately patient-friendly is what we're going for here, and just making sure that we have the right technology in place to support improved access. We have service integration, the SI part of CASI, and that focuses on other technology enhancements that support excellent access. And so just one example that I think many of you all can resonate with is online scheduling, being able to schedule your clinic visit online, self-directed. And we also focus on having the right supports in place for ensuring that our referral processes are tight, that our loops and communication are closed with both our patients and with our referring providers. And finally, we have the Clinical Contact Center and the Patient Access Centers. And these are key entry points for our patients to schedule an outpatient appointment, speak with a nurse for 24/7 medical advice, or for providers seeking consultation. And the Contact Center and the Patient Access Centers together have played a key role in COVID-19 response efforts. And they serve as the primary resource for our patients with questions about needs related to COVID-19. And they also are responsible for scheduling into our respiratory diagnostic centers for COVID tests and evaluations. And I'll tell you, like this, with our increasing volumes, it's really challenged us to think through, what more can we do with the chatbot? How can we ensure that we're best leveraging our highly skilled resources? So I'll hand it over to Andrew.
So I'll introduce myself. I'm Andrew Shirk. I'm a software developer at Procore. Procore is a part of the Lineberger Comprehensive Cancer Center. We build software infrastructure for patient-reported outcomes, and we also help cancer researchers implement and carry out studies using our software. Before Procore and UNC, I was a software architect and developer on numerous digital humanities-related software projects at the University of Illinois. I got my start in the automated learning group at the National Center for Supercomputing Applications, also at Illinois, building infrastructure for our homegrown data mining environment called D2K. I also have a background in art and technology, doing my undergraduate work at the School of the Art Institute of Chicago, which is where I started to program seriously. But my passion for conversational agents really comes from many years of thought and research in my art and now in my occupation into the difficulties of human and machine communication. This was the subject of my graduate research, actually. But with respect to conversational agents, I've only been in healthcare for about 4 years. I'm not a clinician, but a lot of the expertise and I guess the authority that I feel I have in this area comes from a personal health crisis that I experienced for the majority of 2019. So with the best healthcare insurance available, I got extremely acquainted with the myriad problems that patients deal with daily, just trying to access care and move through the glacial process sometimes of diagnosis, treatment, and then recovery. And there's just so many small issues that taken together in this whole experience add up to delayed diagnoses, avoidable surgeries, and ultimately poor outcomes. So my story has a happy ending, but I know that I know now that I could have built conversational agents for my 2019 self to help do things like diagnose my condition and help me with finding the right providers efficiently and scheduling my appointments, instead of playing this waiting game where you do something, you make an appointment, and then you wait, and then, oh, you're at the wrong provider, and you have to wait another month and another month. And when you have a time-sensitive condition, this can have serious long-term effects. So we can do these things in a much shorter period of time and at a much lower cost than what my insurance paid for and what I paid for out of pocket back then. But I want to start with this question here, which is, what is a conversational agent? These come by many names: chatbot, voice bot, virtual assistant, digital assistant. I think most people recognize those terms, and they also recognize the brand names of like Alexa, Nest, Siri, Cortana. However, I don't think many people really understand what they are or how they're built. And this impression has been underscored in the process of preparing this presentation. So I'm gonna just start off here and make sure you understand what I mean when I say conversational agent. So a software application that communicates with a human using natural language. This sentence encapsulates several key concepts. One, you have a software application that is communicating autonomously. There's no person in the background running the show. It's automated. It's a computer program. And then you have a human who is communicating with the software. They're submitting text or voice commands to the software application, and they're getting a response, and they're doing something with it. You know, they're scheduling their appointment, whatever. They're trying to achieve some task. And then you have the means by which the human is interacting with the software. This is the interface, natural language, or something that understands natural language. So i.e. like text, voice, but also image, because I think text, voice, and image are inextricably linked within conversational agents. So here are some popular examples of conversational agents. There's Alexa, which uses speech input, but also has some versions that use image. There are 120 million Alexa devices that have been sold. These are users that are actively purchasing a conversational interface. There's 28,000 smart home devices that work with Alexa. And really, if you have one of these, you might be thinking, well, not much interesting is being done here yet. And I think it's true. I think there's just a ton of potential here for interesting and effective and life-saving healthcare apps. We also have conversations on our phones and our car entertainment and navigation systems. And of course, there's the ubiquitous chat interface, which we've all used. So just important sidebar here. Conversational agents are not new. The idea has been around for 70 years. Alan Turing, who's considered the father of artificial intelligence, discussed this idea in a 1950 paper entitled Computer, Machinery, and Intelligence. It was very groundbreaking, and it's still relevant today. And if you don't know about him or about his writings, you should take a minute to read it. Because it really informs kind of the background, the context of what's happening. And in this paper, he laid out the very rules that we've used to judge the intelligence software for 50 years. So other milestones in conversational agents include ELIZA, which many of you perhaps used, built in 1966, IBM Watson, and then there's Alexa, there's Siri. But back to our sentence. So conversational agents comprise the three main actors: a software application, a human, and the natural language through which they communicate. So hopefully you all tried out the Raffle chatbot and noticed that when you pull it up, you're prompted to register for the raffle. Well, here, these three actors kind of engage. And I like the word actors because it kind of paints the picture of a theatrical scene. And as the chatbot developer, that's what you're doing is you're positioning all these actors in this theatrical event, and you're coordinating these complex interactions that unfold over time. So assuming you, a human interacting with this raffle bot, felt some reservations, you may have opted to see the puppy instead, right? You could have typed it into a field. You could have clicked on a button that contains the text, or you could have said the words out loud to a digital assistant. The point is, when you make that utterance, we call it an utterance, when that's conveyed by the user interface, it goes on to a bot service, the software application in the background. And the bot service then processes the human input using natural language processing and natural language understanding. So the NLP and the NLU are used to kind of distill the human input into a structured ontology that the computer understands. The NLP stage is a mediating event in that it's opaque to most chatbot programmers because it's handled automatically by the bot service toolkit. So after the NLP stage, the bot service toolkit invokes code that best fits the user's intent. Intent is a key word here. It's a key idea. As a chatbot programmer, you set up these different intents, and then the bot framework kind of handles the routing to the appropriate intent. But that core code for the chatbot that the bot framework invokes, that activates the necessary actions to fulfill the user's request. So, for example, in the case of the raffle bot, if the user requests a puppy, the code gets dynamically gets a URL for a new puppy, and that gets returned to the user. So architecturally speaking, you have a UI and you have a bot service. So in this architecture, all that came from this sentence, you could easily reuse the same bot service with a variety of different user interfaces. So whether it's a chat interface like we've seen in Alexa, voice, image, and I've never seen image mentioned as a type of natural language, and you probably won't find it, but I'm thinking more and more that it is, and maybe you should keep it in mind as such, because it's as much as signal carrying information as voice is. It connotes nouns, verbs, adjectives, and most powerful of all, it connotes metaphor. So it's kind of akin to voice in that it's an unstructured signal, and there are now algorithms that translate images, that like annotate images in video descriptions, just like with voice. So if you read the marketing glossies of AI software companies, or you just read the news media, you'll think conversational agents were almost as smart as humans. And all of us know this isn't the case, but it's hard to wrap your head around what a conversational agent can actually do today. So I found this table to be really helpful in describing the kinds of conversational agents that you can build, and like the kind that your mind kind of naturally tries to imagine. And it also helps suss out how smart you can expect them to actually be. I also kind of honed in on this table as a way to isolate what I think of as the sweet spot for conversational agents in health. And that to me is this rule-based quadrant down here, but I'll talk more about that now. So let me try and break this down. Along the x-axis here are the kinds of responses that the conversational agent is capable of producing in response to the questions that the human poses it. So a retrieval-based response means the response is canned, or it's pre-programmed based on some kind of rules. Whereas a generated response is invented out of thin air based on knowledge, so to speak, the conversational agent possesses. This smart machine term is a term from Gartner Research. They think that smart machines will be all the rage in 5 years. And there are a few elite chatbot companies that purport to build these, but they're going to be very, very expensive because this is the super cutting edge. So shifting axes here, along the y-axis, you have the scope of domain knowledge that a particular agent might possess. So open and closed. In an open scenario, you have the agent that is capable of discussing absolutely anything. But in a closed domain scenario, the conversational agent is very knowledgeable about a particular subject, but knows almost nothing else. So we can use this two-way table to say here in the top left quadrant, it is pretty much, it is impossible to have a conversational agent that is able to retrieve any possible question, that is able to retrieve the response to any possible question. You couldn't plan for that as a programmer. So this is impossible. In the top right corner, you have an open domain, but with generated responses. This stuff's invented out of thin air. The responses would look human-like. This is known as, in the artificial intelligence field, as general AI, and this is the holy grail that everybody's going for. This is what AI software companies want you to believe is right around the corner, but you should know that it's not. We really need a major breakthrough in AI research to get anywhere close to this kind of intelligence. So we've eliminated the top row for healthcare agents. So what's left now is closed domain agents. In the bottom right-hand corner, as I said, you have smart machines, which some elite chatbot companies are purporting to build. You could buy one, but it's going to cost a lot. I think you could also build one of these yourself. There are tools and frameworks out there now that you could use for projects like this, but you'll have to do a lot of the development work yourself. I think the biggest cost would be in collecting and curating all the training data that you would need for your domain. So in the bottom left-hand quadrant, you have closed domain agents. These are retrieval-based bots. These are the kind of bots that I am building, and I think there's enormous opportunity here because you can build them affordably. You can build life-saving conversational agents for healthcare here. The software kits are mature, they're ready to go. The raffle bot, which hopefully you all have used now, is a bot of this nature. So all of the problems that I described with my personal healthcare issue could probably be solved with a rule-based closed domain bot. Let's talk briefly about hype. There's a lot of hype around conversational agents. Every year, Gartner Research publishes hype cycles for different areas of tech. This is the one for conversational agent related technologies. The diagram is much more complex, and then I've plucked out AI technologies that are relevant to conversational agents. So you have the innovation trigger. So something happens in the field and there's innovation, then everyone gets really excited and thinks it's the greatest thing since sliced bread, and then everyone realizes it's not, and then finally we become productive. Gartner has general AI as an innovation trigger here. I don't know what this is. I can't find any information on what happened here. I don't think it actually exists. So just keep that in mind. But edge AI is interesting. And what this is AI computing that might happen on Internet of Things devices in our private home networks. Devices that's like the edges of the network, not in the core data centers. And it's definitely getting, this kind of computing is definitely getting a lot of attention. And I'm thinking that it's kind of the killer app for conversational agents in healthcare, because if you have private data, if your data isn't being sent out to the cloud and done who knows what with, there have been several key cloud providers that have been caught kind of with their pants down, so to speak, with our data. But if you can keep it locally in your network, you could perhaps shore up the public's trust in digital assistance. And I think people might become more readily to accept them. So yes, there's 100 million Alexas out there, but in order to get to the next 50% of the population, I think we're going to need a real innovation in trust and security. So yeah, and there's other technologies here, but I'm running short on time, so I'm going to move forward. Chatbots are probably more down here, close to the trough, and that's okay because they're well understood now, and we kind of know what the strengths and weaknesses are, and there's some exciting things that we can do with them now that the reality is upon us. So now I'm gonna Ashley and I are going to talk. Ashley, can you?
Yep, I'm here.
Okay. So there's a bunch of examples of conversational agents that are being used everywhere in healthcare. Customer service is really the low hanging fruit, not only in healthcare, but also in a lot of other domains, because you have like 24-hour availability. There's no call center people that have to be there from 9 to 5. So you have instant answers and on and on. You'll hear more about customer service from Ashley, but there's also patient education, which is happening. There's FAQ bots everywhere. So this is just a collection of frequently asked questions that really is available on the site, on many of these sites, but users have a hard time finding it for whatever reason. And the chats provide a natural interface that, it's not for us, it's not for the techies, it's for more novice users that just don't want to learn a new user interface. They want to just get in there, and find their information using this familiar interface paradigm. Symptom screening. There's a lot of companies doing symptom screening. Buoy Health is one they have a chatbot, and they sell their chatbot to businesses to give to their employees to use as like first line diagnosis and care recommendations. Mental health, there's a lot going on in mental health. I'm hearing a reverberation. Is someone on, not on mute perhaps? Anyway, so Robot is a cognitive behavioral therapy chatbot that grew out of a Stanford research lab, and it's been shown to be clinically effective for reducing symptoms of depression. Replica is a very interesting development recently. It's a smartphone-based app that has gained popularity during COVID, and this is an example of a smart machine bot. So it's kind of the cutting edge. It uses NLP, NLU, natural language processing, natural language understanding, and natural language generation. So it's inventing the responses on the fly. So there's a big article in the New York Times where users talk about the therapeutic effects that they're getting from their digital companion in Replica, and they seem to be very excusing of the imperfections of the virtual agents because they don't get it right. They say weird things sometimes. There's technical problems, but users are finding them valuable. It's really interesting, and actually, just the users interacting with the chatbots is providing crucial training data for deep learning algorithms that power these bots. So now I'm going to kind of let Ashley take it away and provide any further comments on this slide that she'd like.
Yeah, I was just going to kind of go over some of the challenges that we have. So really the key challenge that we have as far as improving access is concerned is rooted in balancing supply and demand. So we're taking you all the way back to your high school econ class. And in most cases where we struggle with access, we have an imbalance of appointment supply or resource supply with the demand that we're getting from patients, whether it be that we're using our supply inefficiently or that there's just not enough of it. So we have to take steps to remedy that imbalance. And for the most part, it means that we have to become more efficient with what we have. And as everyone knows, it's very difficult to gain more resources. So we're having to take close looks at our workflows. We know that chatbots can help us from many angles, some that Andrew mentioned with the customer service aspects and especially providing patient education. And so that's been helpful. I will talk a little bit about some of the ones that we've been leveraging that speak to that directly. And I mentioned this before too, but I think it's worth reemphasizing here is we've learned in, I'll call it the COVID-19 world that we're in, that we must be nimble enough to make speedy adjustments to our processes and workflows. We are continuing to see increasing volumes. We don't have a lot of wiggle room for increasing our resources. And so again, tightening up our processes is the name of the game. We've actually just, a stat to share with you all. We've seen our call volumes coming into our contact center increase by 102%. And this is all coming through our COVID helpline. So, if there's ever a burning platform, this is it. So it's been helpful to see some of this demand help being managed through our chatbots. And so just quickly, I think many of you are probably familiar with UNC Healthcare, but here's our footprint across the state. We are an integrated nonprofit healthcare system owned by the state of North Carolina and raised in Chapel Hill. And we provide comprehensive patient care, we facilitate physician education and research expertise, and promote health and well-being of all North Carolinians. That is our core mission. And we've grown tremendously. I think it was 2013. I could have my dates off here, but that's when we really started our growth from two main hospitals to about 12 hospitals, and I think 13 total entities is our current number. So that's UNC Healthcare. And then I can speak toward each type of bot that we have. These are the three that I'm going to cover: the coronavirus symptoms checker, MyChart patient portal support and the COVID-19 symptom tracker for patients who've had tests. And I have to give credit here to Dr. Arlene Chung. She is the lead on these efforts for the projects. I actually had to familiarize myself with them to be able to do them justice on this call. But I wanted to make sure that, that acknowledgement is given to her, as well as the UNC Health Alliance, which stood up the COVID symptom tracker. So next slide. So our COVID-19 symptom screening, this helps us determine, helps patients determine the appropriate follow-up avenue, whether it's to contact their PCP, to go to virtual care 24/7, or to pick up the phone and call the helpline to speak with a nurse. And so we've got the bot itself scrolling over there on the left. It also directs our patients to our UNC coronavirus website for education and resources. So that essentially sums up this bot. And yep, I think we can go on to the next slide. Our My UNC Chart portal support. So we currently receive about 400 calls a week. Actually, I think it's probably more than that at this point for MyChart support. And typically they involve questions about sign up or forgotten username and password, lab or test result information, i.e. where to find them, how long it's going to take to turn it around, and what's shared electronically. It also directs patients to virtual care, and currently it directs them to the website, but we're working on updating that to include current capability that we have in place for patients to schedule directly online for virtual visits. A really key point here to make here is that there's no personal health information that's transferred from the bot into our EHR. It's HIPAA compliant and secure. So that was something that was enabled the teams to stand this up rather quickly. We didn't get caught in any red tape. We were able to put it up there and immediately start remitting some of these volumes that we were experiencing. The next slide here. We'll go over our COVID-19 symptom tracker, and this is also known as the UNC Health Chats for patients who've had a test. And this is the effort that was led by the UNC Health Alliance. And currently, anyone seen in one of our respiratory diagnostic centers and are tested for COVID is enrolled in the health chat feature. Positive patients remain in the chat for 14 days. Patients waiting on a test remain in the chat until the result is received, and once it is received, the chat ends. Patients can be manually added to the chat, so if there are patients in the ED that need a touch point, but they don't need necessarily daily outreach, they can be manually added. And again, this is all about resource management, right? We're making sure we're diverting our resources to the right places and kind of pairing off some of the things that can be managed by the bot. There's also some conversation and hopefully changes coming to the way the negative results are received via the chat. And really the goal ultimately is to provide the actual result via the chat along with a work note. So that's going to be a cool enhancement that we'll see next. Let's go on to the next slide. This is the challenges that we have, y'all. One of the challenges that we are faced with is our patients have to go in current state from site to site in order to get the information that they need. And this is incredibly time consuming and it's frustrating. The process would really benefit from being consolidated into a bot. I liken this to when I go on a family vacation and I'm trying to compare my Yelp app with my Hotwire app with the other food ratings and where I want to go to help narrow down where I need to be. So chatbots can help with this. So for the healthcare example, though, if I'm trying to find a new provider in my area, I'm going to think through the following variables. Who's available for online scheduling? We know from our consumer research that patients are actually willing to travel if a provider has online scheduling versus a provider doesn't. And they'll choose that over convenience, which I thought was, in terms of proximity, which I thought was very interesting. Information about ratings and reviews. I want to know where my provider ranks among others. Who's close to my house or to my work location? Does the provider take my insurance? Does the provider specialize in the problem that I'm experiencing? And then in my ideal dream world, I'm hoping for which provider has the shortest wait times. And this is a future desire. We've made some steps toward it from a provider finder perspective. But how neat would it be to know how quickly you can get in for an appointment up front versus having to call around or check around on various online scheduling forums. And one thing I just want to kind of link up to here that's really important, UNC Health has done some consumer research, and we found that we absolutely have to make this easy for our patients, or we run the risk of having a shock to you all. Convenience is key in these days. We want our supply on demand, as we heard last year in another speaker forum that I attended. And so we want to make sure that our patients are continuing to manage their health during the pandemic, and safety messaging really has been key. And we also acknowledge that if we don't do this, if we don't make this easy for our patients, they're going to go somewhere else. There are plenty of excellent choices in our area, and that's why we really have to make it easy. So let's see, the next slide here, we'll talk a little bit about triage, so how chatbots can help with this. And so one of the first things in our endeavor to free up our scarce nursing resources is thinking through symptom screening. Can we sift out common conditions like flu and colds so that resources are focused on patients truly needing triage and follow-up? And this could also give patients an option to schedule a virtual visit. So that's basically, it's completely self-directed throughout the entire process without having to touch a human being. And then of course, diverted to a clinical resource as appropriate. We'd also want specialty-based symptom screening. So questions about pregnancy or chronic condition management. Again, pointing the patient to an appointment when it's needed, or a clinical resource. Next slide. And we'd also like to see how we can improve care delivery by engaging our patients in the chats. Symptom monitoring is one thing to keep patients engaged in their care. I gave an example of that with our COVID test monitoring. A patient remains positive, they stay in the chat for 14 days. It could also be disease or diagnosis specific. And I think through like examples as cancer or pregnancy or diabetes. One personal example I thought of was postpartum follow-up well-being assessment. So I recently had a baby, and I'll tell you, I probably filled out the well-being form about 8 times with the same answers that would have been helpful to just kind of handle within a bot before my appointment. Pre and post follow-up, post-op follow-up. So instructions for patients to know before they arrive, or things that they should know. And then just really that's an effort to manage expectations. And then post-operative care, things to watch out for. I know that when you're discharged from the hospital, you're not really feeling 100%, so you're not necessarily going to remember everything they told you. So this is where it would be incredibly helpful. And then monitoring responses to new medications. And we can build in, my understanding is that we can build in triggers that can prompt a phone call from a nurse. And this also provides peace of mind too, right? So if they're stepping through the process and they know that some of these side effects are normal or typical based on the responses, but then also some that aren't, they can sort those out and proceed as appropriate with support from the bot. And then the next slide. So provider electronic health record support, EHR. We would like to be able to identify providers to engage in consults. And so this is really taking this a step beyond what's available within our own EHR, what's available within UNC. So for example, if I'm a provider at UNC Family Medicine in Chapel Hill and I want to know who specializes in migraines in New Hanover County, I'll be able to easily find that information without having to consult multiple resources. And similarly, bots can be used to connect providers with a specialty or versus a specific provider. So similar use case as the one I just outlined, looking for something in the patient's hometown, making that direct connection. And then we also have potential opportunity to enhance our best practice advisories in our EHR, and we can make our algorithms more dynamic where we have the opportunity to better engage our providers versus having a pop-up, which I think everybody's pretty much sick of pop-ups at this point. Just hit OK and proceed on to the next thing. So it's a little bit something different to look at. And then finally, on to the next slide here, we had a couple other ideas that could help us support operations. And so, especially in this COVID-19 world that we're in, things are changing on a daily basis. It seems like we are reframing our messaging. We're having to make adjustments in various clinics to how we're approaching patient safety. And it's good to be able to be nimble, to communicate with our patients and what exactly is going on in the clinic that they are actually going to go see. So what to expect, maybe they need to wait in their car before coming into the clinic, that they'll be giving a mask, that their temperature will be taken, things of that nature that could vary from clinic to clinic. That we could at least tailor that to the clinic at hand. And similarly with surgery and procedure prep expectations, what are some of the measures that we are taking to ensure patient safety that they'll experience before they've arrived, so it's really not a surprise that they build in enough time to make sure they get to their appointment on time, and then they know what to expect when they get there. So I've come to the conclusion of my section. I'm going to hand it over to Andrew to dig into the details, the technical details.
All right, well, we don't have a whole lot of time left. So I want to leave time for Q&A, but I want to briefly just touch on a few deeper issues regarding how the actual bot service works. And I'll say that there's tons of options in terms of how you build your bot service. These companies all provide mature frameworks for building bot services. Amazon AWS has the Lex service, which is what we've been using. Microsoft has a very nice bot framework. There's Watson. Rasa is kind of the odd one here in that it provides tools to really, it allows you to do everything you want. If you're a very skilled developer and you want control over the natural language processing and understanding component, then it will give you that control. And it's an area that I'm interested in exploring, but we haven't gotten there yet. So let's take this sentence that you essentially submitted to Lex when you clicked the button that you'd like to register for the raffle. What happens when you click that button? We've discussed it so far in that it sends the user interface sends a message to the bot service, and at that point, the bot service, in our case, Lex, it takes that sentence and it breaks it down into the structured ontology that it understands. And what it does is it takes these bits of information, it converts, the words to numbers, and then uses complex statistical processing to figure out which intent best matches the sentence that's being submitted from the user. In this case, it would map the sentence to the register intent. So the idea is, I have these three intents: register, draw winner, and show puppy. These are all defined in my bot. This is the whole scope of my bot. And one of these intents, register, would get invoked by AWS. But at first it would see that there's no other data about the registration available. So Lex would just turn around and provide a response, which is, what's your first name? And at that point, it starts collecting information. So you all experience this interaction that happens between the bot, back and forth, collecting information. The bot is pretty simple, but you'd be surprised just how many more validation nuances you have to kind of account for. Also, things happening out of order. But when you do submit and complete your registration, what happens is, Lex then routes the request down to this Lambda level. Lambdas are what are known as serverless functions. So these are just little bits of code that you can associate with the intents in the intent editor, which I'll show you here in a second. And then the data gets saved to a database. And in our case, we're using AWS DynamoDB, but you could use any database you want. And then imagine if you said you'd rather see a puppy, then AWS would route the puppy request down to this Lambda, and the puppy Lambda would go and go to this puppy service where it gets a new image and then returns it back. And we showed a diagram of that earlier. So this is the AWS Lex bot, like intent editor. So everything that I'll show you here is what makes up the intent and this register intent specifically. So at the top here, you have sample utterances. As a chatbot programmer, you enter in all these different sample utterances, and AWS trains its machine learning on what you enter here. So there's a build button here at the top. When you click this build button, the Amazon magic crunches all this stuff and trains a model for processing, for natural language processing. These are slots. Slots is a key idea. These are like variables that have to be filled up in the course of interacting with the bot for this intent. And then once the bot sees that all the variables are filled up, then it calls a fulfillment function, which you can select here. So as a chatbot programmer, you'd select which Lambda function you want to run once Lex sees that all these variables are filled. So this is really, really cool stuff. And you can see these are all the intents here that make up the raffle bot. So now I'm going to show you what's just a snippet of the Lambda code that is used for the raffle bot. Down here at the bottom, this is where Lex hooks into all of the magic. So Lex will just call this function here, and when the Lambda is invoked, and then in the scenario that I'm showing you here, I've programmed the bot to handle like all three intents, but you can think of them mentally, conceptually as separate intents. But this Lambda then looks at what the intent is and calls the necessary intent code. So in the case of register, it would call a register function. In the case of draw winner, and then show puppy. So we've talked about the show puppy. So I'm going to show you what the show puppy looks like. This is really all it is. And I have a backup puppy URL in case the main puppy service is down. I have a dynamic selection of emoji to display with the nudge, the prompt to come on, man, register. And then I call the puppy service here to get a new puppy URL, and then in all this code, it's constructing the response to the user, to the user interface that contains the URL. And then here is the DynamoDB, which is another AWS Lex service. There are many services in AWS Lex, and you can kind of choose them as you need them. But this is a NoSQL database, and there's just two tables. The raffles that I'm holding, I'm going to be holding a lot of raffles, just kidding. And then the data that's made up of those tables. So I think I'm going to stop here. And we'll start to take some questions. We also have to, let me just blow through this section here. Before we start taking questions, I'd like to just say thank you to Kieran and the other organizers at Digital Health for setting all this up and working through arranging the presentation. I also want to thank Luke Eshelman, who helped me build the raffle bot, and I want to thank Matthias Johnson and the UNC Procore folks for inspiring me all the time. So let's draw the winner of the chatbot here. Sorry, of the raffle. We'll go to. Oh, registration's closed. Oh my God. Okay. Oh boy. Okay. This is going to take some finagling because I waited too long, and now registration is closed. I need to, it's not going to give me a text input. I'm sorry, folks. It would take me a few minutes to update the date in the database. Let me see if I can do this real quick. Actually, let's start taking questions, and I'll see if I can fix this, and we'll come back and try to draw a winner before the end of the meeting.
Sure. Thanks, Andrew. Thank you very much, Ashley. So we have, I think, 3 questions. I'll start with Ashley. So Ashley, there is a question. Do you see merits of integrating chatbot into EMR via standard such as FHIR? So what's the status of integration with EHR and UNC?
Yeah, I mean, and I'm just going to go off the cuff here because I'm thinking of things that could be useful in operations. And one of the first things is anytime we implement something new in our EHR, being able to leverage it as a communication tool for schedulers or providers in real time, or nurses, basically just end users of the AHR, and it would essentially be prompted whenever they're in that new location where something has changed. And then I think the other thing too, just to keep in mind, I mentioned the best practice advisories, and that could be one way of kind of redesigning some of the things that we already have that are in the form of pop-ups. I think with anything, you have to be very careful about how often it's used. You can't just take like, this is the be-all end-all solution and put them everywhere, because then people get chatbot fatigue, if you will. And so you'd have to be very deliberate about where to use them. But absolutely, I'd love to see that.
Great. Thanks, Ashley. So there is another question. So have there been chatbots that extract from the EHR data to personalize the answers, or does it come from a separate source?
I'm not sure about that one, but I'm pretty confident it could be done. I don't have direct experience with that, but I mean, I think that's where you start getting into some of the security challenges. But no challenge is insurmountable. So it's certainly something that we would want to see in our future.
So there is another question about privacy, but it's more specific to IoT devices. So I don't know who can answer this, whether it's you or Andrew. But for better privacy, do you know of any chat services that run locally on an IoT device? Question is, doesn't send any data to the cloud.
There are some digital assistants that are in production that keep data locally. I don't think they've gotten much traction yet, but I could check more on that. I think this is part of the whole edge AI equation, and it's something that is coming down the pike more.
Oh, have you got any feedback from physicians and consumers on this agent? And if you got some feedback, what are they?
Yeah, I was just making sure. I was looking to see if I could pull up some of my my data here, but so far the data has been very promising. The feedback has been positive. So for the MyUNC chart support bot, it's answered 13,800 questions related to the patient portal. So that, I mean, think about that. That could have been phone calls. Coronavirus self-assessment tool has assisted 21,000 patients to self-triage for COVID-19. Our follow-up chats have served almost 23,000 patients monitored to date. And these are all completed chats too. This is not something that where the patient has essentially failed from the workflow. And then there are some transitions of care chats as well that we didn't mention on this call, but with regard to COPD, acute myocardial infarction, and CHF, congestive heart failure, and that's in the pilot phase. But so far we have received that when we need to make an adjustment, we can do it rather quickly.
Awesome. Well, looks like sorry, there is an echo. So looks like the chatbot winner is there. So Andrew, do you want to go ahead and announce?
Yes, we have a winner. Robert Y is our winner, and you will be contacted to get your new Alexa. I'll need your mailing information if I don't know you. Since there's a Y, I'm not sure who you are, but congratulations. You now have a digital assistant.
Awesome. Robert, are you there? I mean, if you...
Yeah, I'll see if I can.
I don't think he's there in the list, you know, probably might have left or something. If Robert, if you are there, just put something in the chat message.
We could draw a new one if they're not here. We could.
Okay. So while that's going on.
Sorry?
Lauren Cripps.
Is Lauren Cripps here?
I am.
Oh, there you go. Awesome. Congratulations,
Thank you
Lauren.
so much.
You're welcome. Is this your luckiest day ever?
I'm actually, I have to say I'm really good at winning raffles for whatever reason. So. But thank you guys for the presentation. It's really interesting to hear about all these things that UNC Health is thinking about. I really like hearing about that. I really hope that this is the future of some of our you know, healthcare, where it's moving. It would be great to be able to take advantage of some of this now, but unfortunately I'm not in the UNC area. But really great presentation, guys. Thank you.
Thank you. Thank you very much.
Thank you.
Sorry for the technical difficulties at the beginning, but you know, there's always something. The demo gods. Yeah.
It worked out very well. Well, one question I have is this, you know, are these voice requests or commands from the users are being stored?
It depends on what framework you're using. Yes, Lex, you know, Amazon does store them, and they do not make them very easy to get a handle of, on. In fact, this is one of the really strong arguments for using, I briefly showed the RASA framework logo. That would give you, you know, ultimate control over all the data you collect. You could train your own learning algorithms, and you could kind of see at a better granularity what's happening with the NLP layer. Yeah.
Awesome. I think we are out of time. Thank you very much for attending all this. And thank you very much, Andrew and Ashley. It's a wonderful presentation and topic. And we will put the link to the recording of this event, so that will be available through our Meetup site. So any last thoughts, Andrew, Ashley?
No, just thank you all for coming. This has been a pleasure. And I'm glad that eventually everything got worked out. So
Thank you all. Appreciate you attending today.
Thank you very much. Bye, everyone.
Bye.